Hello, good people. Welcome to the next video here. We're still working with the fundamental theorem of calculus, and we're working with it in terms of this accumulation model as a way to figure out function values when I'm not given the function equation, but instead I'm given the rate of change of the function equation whose value I'm looking for. That's a long way to say this. Here we have example 2. We have a function little g of x is equal to the natural log of the absolute value of all of this stuff. But we want to know what is G, capital G of 4, if we know capital G of negative 3 is 6. So again, whenever you see a capital letter function, it is the antiderivative of the lowercase letter function. Or another way to think about it is the derivative of this capital G is little g. So I'm going to take the integral. I'm going to choose the lower value first on the bottom, higher value on the top of little g of x dx, because I know that by the fundamental theorem, if I take the antiderivative of little g, which is capital G, then I'll get this minus g of negative 3. But we already know g of negative 3. G of negative 3 is 6. So if I replace this with 6 and then I add it to the other side, then I'll get 6 plus the integral from negative 3 to 4 of g of x dx will be what I'm looking for, which is g of 4. Okay, so I'm going to go ahead and put this in my calculator to figure that out. But I do notice that I'm going to have to do this several times. I'm going to do one more out of this example, and then we'll go to the next video. But because I'm going to do multiple problems of the same function, I'm going to go ahead and put the natural log of x squared plus 3x plus 2, absolute value of x squared plus 3x plus 2 in my calculator. So I'm going to go over here. I'm going to go to y equals. I'm going to erase this. I'm going to put the natural log of the absolute value. Absolute value is located in math, and it's a number operation. So we go over to num, and it's the first thing you see there, abs. So it's the natural log of the absolute value of x squared plus 3x plus 2. And then I will close that out. Let me double check that that is the actual equation. X squared plus 3x plus 2. Yes. Natural log of the absolute value of that. And so I come to the home screen, second mode. And let's erase all this business. So we know that the initial value is 6 plus. Now we're going to do the definite integral. So the definite integral is going to allow me to figure this out on the calculator. If I go to math, option number 9, and we're going to go, if I don't remember, we're going to go from negative 3 to 4, from negative 3 until 4 of this function that I just saved in y1. So if I do alpha trace, there's my list of all the functions. I'm going to choose the one I saved in y1 and do dx. Remember, I'm already adding on the initial amount 6 plus whatever this net change is. That's going to give me the final amount, which in this case would be yada, 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 about 12.184. So this is about 12.184. That's how much g of 4 equals. Yes? Now what happens if I'm asked to find g of negative 7? Notice that this x value smaller than that x value. Well, I would normally set up the integral from negative 7, the smaller x value, to the upper or bigger x value of g of x. And that would equal g of negative 3 minus g of negative 7. Okay. Knowing that, I'm looking for g of negative 7, but I'm subtracting it. So let me add it to the other side, and then let me subtract this to the other side. Another way to think about it is I'm going to subtract this to this side and then change the sign so that I can change this negative into a positive. However you want to move it around algebraically, as long as you have g of negative 7 by itself, and then you'll have g of negative 3 minus the integral from negative 7 to negative 3 of g of x dx. right? Algebraically, you can do it several ways, but in the end, we're going to come up with something like this. We know that g of negative 3 is 6. So 6 minus, we know that this is 6, minus that integral is going to give me the value that I want. Because if you think about it, this is saying the ending value minus the net change will equal the starting value. So I'm going to go to my calculator, and I'm going to say this times 6 minus the definite integral. So I'm going to go to math, option number 9. We were going from negative 7 to negative 3 of that function that I already saved, alpha trace 1 in y1. And let's, oh, not a, x. And if I press enter, about negative 3.411, your answer has to be correct to up to 3 decimal places, accurate to 3 decimal places. You can put 4 decimal places, but negative 3.411 would get you the credit. So this is about negative 3.411. And that's how we set up the accumulation model, which is a consequence of the fundamental theorem of calculus. Whenever we're looking for a function value and they give me a rate, I can use this model to figure that out. On the next video, we'll do some graphs, and that will help us kind of cement this idea a little bit better.